Hello and welcome to this Python video. Today we are going to be looking at the np.linspace function. And the linspace function is a simple but a very helpful function. And in essence, what it does is it spits out a 1D array of evenly spaced numbers over a certain interval that you give it. So if we write it in here, np.linspace, just like that, assuming that you've already imported NumPy, just like import NumPy as np, it's like that. There are going to be three main parameters that we look at: start, stop, and num. So essentially, the linspace function is going to return num amount of numbers over the interval start to stop. Now, let's see an example of that to make it a bit clearer. So if we set start is equal to 100, stop as 200, and we'll set num to 5. Now, if we run that there, you'll see that we get our array with 5 numbers, as we specified here, from 100 to 200, and they're all evenly spaced, so 25 apart. Now, start and stop are essential parameters that you need to include, but num is optional and by default is set to 50. So if we get rid of this line here and we take num out here, you'll see that we get 50 numbers between 100 and 200, all evenly spaced. Now, when would we actually use the linspace function? When is it useful? Well, if we look up here, we've got some temperature data in an array. And this has been taken from a sensor which was running for 1 hour and took a temperature reading at a constant rate. So it was always the same interval between temperature readings, but we're not quite sure what that is. So if we wanted to graph our function with the temperature on the y-axis, currently the x-axis isn't really that meaningful. So if we do that now, plt.plot temp data, you'll see we get this here, and the x-axis currently, all that's showing is the number of the reading. So, the first reading, the second reading, when actually we want that to be something a bit more useful, like the time that each reading was taken at. So all we have to do is define an x-axis, and we'll use linspace. And this is going to be the times. So the first time will have been at 0 seconds. And because we know this experiment was an hour long, we know that there's going to be 3,600 seconds at the end. And now all we need is the number of readings. And to do that, all we need to take a look at is the length of our data. Now that we've done that, we can just put this x into the x-axis here. And when we rerun that, you'll see that the x-axis now corresponds to the time at which each reading was taken, and it didn't require us to figure out how long each interval was. Now, another time when linspace is useful is when you want to graph a mathematical function like y equals cos of x. Because this function is continuous, we can use the linspace function to generate ourselves a domain. So if we wanted to plot y equals cos x between the points 50 and minus 50, we just set our x as the linspace between minus 50 and 50. And because that's array, we can use the np.cos function, which will spit out another array using that. And so if we just plot that like this, you can see that we get our cosine wave. But at the moment, it doesn't look very good. It's very jagged, and that's because by default, we said the num was 50, so it's quite low resolution right now. So if we set the num equal to something like 100, you can see that's slightly better. But if we want to get it smooth, we have to set it to something higher. And when we look at 500, that seems to be fairly good. We can go up as high as 10,000, but that's going to use up a lot more memory and processing power. So just to reiterate, the NumPy linspace function is incredibly useful for lots of graphing uses and essentially just making a linear space, hence the name. Especially this last example we've seen here with graphing functions, you'll certainly be using that a lot, and you can do it with any kind of function, especially polynomials you'll probably see. And I hope this video was useful to you, and thank you for watching.